This lesson is going to be about the Pythagorean trigonometric identities. I'm going to give you the background of it, so hopefully you can understand where these are coming from. Okay, so if I have my unit circle, I just put on there, that means from the center point, 0, 0, to the outer edge is 1, 0, giving me a distance or a radius of my circle is 1. So no matter where I was on the circle, coming out from the center, I'm going to have a radius of 1. So I want to talk about where this Pythagorean triple comes from, using the Pythagorean theorem. So I'm going to draw a angle coming out from my center. That angle is going to be theta. I know that this radius is 1. If I wanted to figure out my sides of my triangle, if I was making a right triangle, I would drop down my horizontal and if I was to measure that length, since it's a horizontal line, I know that length is a y value. So now I could draw in my base of my triangle, which I know is going to be an x value. If you remember us talking about x and y values on the unit circle, x and y goes with cosine of theta and sine of theta. So really, this x value is the cosine value of whatever that angle is. And my y value is equal to the sine value of whatever my angle is. So if I wanted to figure out my first Pythagorean triple, or not triple, sorry, identity, using the Pythagorean theorem, I would have x squared plus y squared equals, my radius is 1, so 1 squared. So really I have x squared plus y squared equals 1. If I plug in my cosine and my sine values, I would get cosine squared, so cosine of theta, all squared, plus my y is my sine, so sine of theta, all squared, and it's still going to equal 1, because that radius is not changing. It's still going to be 1 squared. So 1 squared would be 1. So if I write it with the shorthand, remember cosine squared theta is how to write cosine theta all squared plus sine squared equals 1. And that is your first Pythagorean identity. And again, it's something that you need to remember for the regions. They don't give it to you, and they like to use this one the most often. So cosine squared plus sine squared equals 1. Or they can reverse it and say sine squared theta plus cosine squared theta equals 1. Either way, it's the same. That's just using the commutative property and rearranging it. So now we'll do another one. So I'm going to get my second Pythagorean identity using my first Pythagorean identity. So my first one's sine squared theta plus cosine squared theta equals 1. I want to change this identity into something different. Another triple. So I know sine divided by cosine is tangent. So if I take this identity, sine squared theta plus cosine squared theta equals 1, and divide each term by cosine squared theta, I'm going to change it to a different identity, rearranging each term. So since I know sine squared theta divided by cosine squared theta, sine over cosine is tangent. So I'd have tangent squared theta. If I divide cosine squared by cosine squared, when you divide a term by itself, you end up with 1. And 1 divided by cosine squared, since 1 over cosine's the reciprocal of cosine, and I know the reciprocal of cosine is secant squared theta. The only time 1 over cosine turns into a square is if the cosine originally is squared. So that's why I have secant squared instead of just secant. So this is the second Pythagorean identity, something that they don't give you, again, on the reference table. Honestly, as long as you remember sine squared theta plus cosine squared theta equals 1, this first Pythagorean identity, this is the one that's used most often, is sine squared theta plus cosine squared theta equals 1. Or they could put in x's instead of thetas. They could put in any variable that they want instead of thetas. But as long as you remember that one, you can change sine squared into tangent as long as you divide every term by cosine. So that's the second Pythagorean identity. The third Pythagorean identity is also going to stem off of the first one. That comes from the Pythagorean theorem. That's why it's called a Pythagorean identity. So sine squared theta plus cosine squared theta equals 1. Now, instead of changing sine squared into tangent, I'm going to change cosine squared into cotangent. And the only way to do that is cosine over sine will become cotangent. So that's what I need to divide each term by, because once you divide one, you have to divide all of them. So I'm dividing all of them by sine squared theta. And the reason I'm dividing it by another term is just to rearrange everything. You're changing what it looks like, but it's not changing the value of it. So if I divide sine squared by sine squared, I end up with 1. Cosine squared divided by sine squared ends up being cotangent squared. And 1 over sine squared ends up being
Mrs. Packard, please call the
cosecant squared. And that's the third Pythagorean identity.